Dear colleagues, welcome to our poster. My name is Boruvka. I am from the Czech University of Life Sciences Prague, Czech Republic, and I am presenting a study on forest soil acidification risk assessment in the Czech Republic using the digital soil mapping tools. We worked on it together with the Forestry and Game Management Research Institute at Masaryk University. The study focuses on forest soils in the Czech Republic that were strongly impacted by acid deposition in the 20th century. It tried to map the state and risk of forest soil acidification using a large compiled forest soil property database and digital soil mapping tools. The soil data originate from several large-scale surveys done by several research institutions. We focused on mineral soils, namely the layers 0 to 30 centimeters, where we have more than 8,000 sampling points, and 30 to 80 centimeters. The data come from the period 2000 to 2020. Data harmonization and standardization was needed, as well as recalculation to these unified depth layers. The auxiliary data in prediction models included terrain attributes, forest types and typology, soil classification, and climatic data. After testing several prediction model types, we used the random forest prediction model with five-fold cross-validation. These maps show predicted spatial distribution of the most important soil properties considered in the forest soil acidification assessment. We can see that forest soils are mostly strongly to very strongly acid with very low content of exchangeable base nutrients, calcium and magnesium, combined with low available phosphorus content. The only base nutrient with sufficient content is potassium. Base saturation is mostly low to very low. This table shows the criteria defining several acidification risk categories. While the soils with no or very low risk have rather high pH and base saturation and carbonates and silicates as the prevailing buffering system, the high and extreme risk categories buffer mainly by reactions on aluminum and iron minerals. These maps show the predicted distribution of acidification risk categories separately for the two mineral layers. We can see that most soils were assigned to the category high and extreme risk, and that the situation is worse in the upper mineral layer, 0 to 30 centimeters, compared to the deeper layer. As the categories were often different in the two layers, we divided the combinations of categories in the two depth layers to define the whole mineral profile acidification risk categories. And this is the final map of the acidification risk categories in the whole mineral soil profiles. We can see that the categories of strongly and extremely endangered soils are dominant in the whole country, even in the lowlands, while the little endangered soils are rather rare. We can thus conclude that the forest soils in the Czech Republic are mostly acid and strongly acid, with very low base saturation and often with insufficient content of available calcium, magnesium and phosphorus, even at lower altitudes. More than 75% of the forest soils were classified as strongly to extremely endangered by acidification. Attention should be paid to forest floor as the major source of tree nutrients. This research was supported by the Ministry of Agriculture of the Czech Republic. Here you can see my email address if you have any questions, and I will be happy to meet you physically in the poster in Glasgow. Thank you for your attention.